As dear students, I want to discuss one more problem related to Ohm's law. See, the problem is the potential difference between the terminals of an electrical heater is 60 volt. So when it draws a current of 4 ampere from the source, so what current will the heater draw if the potential difference is increased to 120 volt? What they given, first we have to understand the problem. Here linking of problem is that the potential difference between the terminals of an electrical heater is 60 volt when it draws a current of 4 ampere, right or not? So initially they given potential difference or voltage they given and current they given, right? So after that, so what current will heater draw if the potential difference is increased to 120 volt? So in the first problem up to here they given potential difference and current. From that we can calculate resistance. First we want to calculate that. They given V equal to 60 volt, I equal to 4A. Then from Ohm's law V equal to IR, then R equal to V by I. Then R equal to 60 volt by 4 ampere. Then R equal to 15 ohm. Now after that we have to calculate what current will the heater draw if the potential difference is increased to 120 volt. If you increase the potential difference from 60 volt to 120 volt, how much current the heater will draw? But we know resistance we know, potential difference we know, then easily we can calculate current. So that one I am using here. See, so when the potential difference is increased to 120 volt, then the current is given by we know V equal to IR, then I equal to V by R. Why? Because we know potential difference we increased to 60 to 120 volt, and resistance already we got 15 ohm. So I substituted here 120 by 50, then current equal to 8 ampere. So initially the current how much they given 4 ampere. So it draws a 4 ampere for 60 volts, right? So if you increase 60 volt to 120 volt, then double, right? 60 into 2, 120. So here also 4 into 2. This current also increases 2 times. Potential difference increases to 2 times, how much current we will get? But we know indirectly V is directly proportional to E, I, right or not? That is only Ohm's law. Potential difference always directly proportional to I. So if you increase this potential difference into 2 times, then current also increases into 2 times. That you have to understand, right? Of course, we are without solving also we can easily tell. Understand? So in the problem again I am repeating, in the problem they told if you increase the potential difference 60 volt to 120 volt, it means they are increasing 2 times, 60 into 2 times, then you will get 120. So then how much current? Then here also 4 into 2. Why? Because potential difference and current will be directly proportional to each other. Yes. And the next problem, it is I think related to resistivity problem. See, the problem is resistance of a metal wire of a length 1 meter is 26 ohm at a 20 degrees centigrade. The diameter of the wire is 0.3 millimeter. Just remember that. So what will be the resistivity of the metal at that temperature, and predict the material of the wire using the table 12.2 also, right? So what they given, are they given 26 ohm, right? And diameter they given 0.3 millimeter they given, and length also they given 1 meter. But we have to change this millimeter in the form of a meter. Why? Because if the answer should be in the SI unit only. Then D, diameter equal to 0.3 millimeter. So 1 millimeter equal to 10 power of minus 3 meter. 1 millimeter equal to how many meters? 1 millimeter equal to 10 power of minus 3 meters. Then 0.3 into 10 power of minus 3 meter is nothing but 3 into 10 power of minus 4 meter, right? But we know the area of the wire. So this is for example, if you take a conductor, so it is the area of cross section. This is the area of the wire, formula is pi r square. So but we know r equal to d by 2. Why? Because they given they are not given radius, they given diameter. So for that only radius equal to d by 2, I substituted in the place of r d by 2. Then it is a d by 2 whole square. Then d square by 4. Then area is a pi d square by 4. Right or not? What is how much area? Pi d square by 4. So then we can use a formula, resistivity. How to find out here resistivity? What is that? See, what will be the resistivity of the metal at that temperature, and predict the material of the wire using the table also. But we know R is directly proportional to L and R is inversely proportional to 1 by A. Then combining both equations, R is directly proportional to L by A. Then to remove that proportional to R equal to rho L by A, then rho equal to RA by L. Understand? Yes, that one I am using this formula, rho equal to RA by L. Then rho equal to RA into A means what? Pi d square by 4 by L. Already I told A means pi d square by 4 by L. See, then rho equal to R means 26 ohm they given, pi means 22 by 7, d square means d means 3 into 10 power of minus 4 whole square by 4 into 1. So you can calculate all these 1, I mean you can do, then finally you get 1.84 into 10 power of minus 6 ohm meter, right? Yes. So here the resistivity of metal at 20 degrees centigrade is 1.84 into 10 power of minus 6 ohm meter. So from that table what means you can see, so this is the resistivity of manganese, resistivity of manganese. Yes. So see the next problem. A wire of given material having a length L and area of cross section A has a resistance of 4 ohm. So what would be the resistance of another wire of the same material having a length L by 2 and area of cross section 2A, right? Just you have to read one more time the problem. They given a wire of given material having length L and area of cross section A has resistance is 4 ohm. So they given C, they given first initially length they given, area they given, and this R also they given, 4 ohm they given, right? So what would be the resistance of another wire? This is for particular wire. For example, if you take A and another wire you can take B, what would be the resistance of another wire of the same material having, of course the material same. Material same is resistivity also same. So material having length L by 2, L by 2 they given length L by 2, and area of cross section 2A, area of cross section 2A, but here we have to find out R, right? Yes, but resistivity is same. Why? Because they told same material. See here they mentioned same material. Resistivity is same for both cases. Already told resistivity is dependent on nature of the material and its temperature. So see for first case they given, I am writing here R1 equal to 4 ohm. So then I am using the formula R equal to rho L by A, right? And R2 equal to rho L by 2 by 2A, right? L means L by 2, A means 2A. So then this 2 goes to numerator, then 2 into 2, 4, then rho L by 4A, right? R2 equal to how much? R2 equal to rho L by 2 by 2A, then R2 equal to rho L by 4A. So I take common 1 by 4 outside, then R2 equal to 1 by 4 into rho L by A. But we know from first equation, so rho L by A is nothing but R1, that is nothing but 4 ohm. That I mentioned here. Then rho L by A equal to 4 ohm. Then it is so rho L by A is nothing but R1. R1 is nothing but what? 4 ohm. Then this 4 cancel each other. Then R2 equal to 1 ohm. Understand? This is a very, very important model problem, dear students. If you have any doubt, you can ask me, no problem. See, dear students, I want to discuss the one more concept, that is the resistance of a system of resistors. So that I will discuss next class.